Uh, oh, I wasn't live yet. I am live now? I am live now. Yes, right. Then I can put. I'm not going to use a second screen. This is just, let's just check the sound real quick. Okay, I like this. Um, wasn't there like a thing for the uh, mm, pop-out chat? Excellent. I can be like a professional streamer. Let me go back to my OBS and this time actually change the scene. Here we go. This was YouTube. Ha! Here's one I made earlier. Um, let's run it again. Today, I know that I know that my live streams have been, of late, have been A-level stuff. So I want to talk about a concept that technically is like only, much to my chagrin, only introduced at A level, but I believe can be learned much sooner and indeed for a while was. I'll go back a little bit on this and the history of Turtle and its connection to functional programming, programming paradigm. I'm going to start just day after tomorrow with year 13, and that uses recursion heavily. So this is little sketch uses Turtle to draw a series of branches, a tree. The shape of it is all can all be controlled by parameters using recursion. So it was a Y shape, and at the end of this it was a smaller Y shape, and at the end of those it was a smaller Y shape, etc., etc., etc. So without further ado, I think you open this one and create. We're going to take a turtle, Python with turtle, and we're going to call it turtle all the way down the call stack. Right, turtle is it's an old little thing that dates back to Logo Turtle and the work of Simo Papert. In particular, his 1985, I believe, seminal book Mindstorms about computer science and computer science education in particular, and the idea that children like are natural, not just natural learners, but natural builders of effectively model words that allow them to have a sort of rich learning experience. All very interesting. And Simo Perfect, 1967, and Logo was a teaching language with linked with turtle graphics. That's the most feature is a turtle, so it was a teaching language, but that came with a little graphic turtle, which is nice because then, especially if you're young, you see things more interesting than some text on the terminal. And in particular, but Logo was a dialect of Lisp, which is a functional programming language. And people have been saying that like Logo was Lisp masquerading as BASIC, BASIC being another entry-level programming language. And let me zoom in a little bit. Much like Snap is Scheme, which is sort of the step in between Lisp and Haskell, if that means anything to you, masquerading as Scratch, which again, a bit of a deep cut. So this kind of work, but yeah, here's the problem. I think this must be something in an update in Replit, not login. I'm just going to put a. I don't know my functions today. I'm going to put a little input because so that we wait so that the sketch keeps running, because otherwise this immediately disappears. I think setup will accept pixels rather than, and I can, yeah, I can full screen this to get a bit more real estate. I've hidden my favorite var. Can I hide the address bar? Ooh, hey, that's cool. I don't know how. Yeah, I don't know how I switch tabs now. Control page up, control page down. That'll do nicely. Still no one. But I need to restore the chat because it's popped out. Okay. Right. That's turtle. I have a turtle, not 700. Yeah, 700, 700. T is my turtle, and then okay, we're going to do this 4 times, changing color every time. We set the color to red, or and green and blue and yellow, and then we go forward 75 pixels, and then turn right, turn left by 90 degrees, and then that's done it again, and we get this multicolored box. Right, I'm going to go for screen BG color. We're going to go for, is it just, yeah, BG color. Going for dark mode. We can just do black. 700 by 700, T equal turtle. I'm going to say T go to, so 700 and 700, I'm going to want it, that's centered, 0 is here. This is a proper coordinate system, not like in processing. So I'm going to want, what am I, no, I'm going to want 350, 0, no, sorry, 0, so like middle, left, right, but 350, very top of the screen. Let's do, I think, let's see if that works. Just to see, I think this is going to draw. It might have drawn black on black, so it doesn't really matter. And then T, so the turtle will be pointing east, forgive me, east on the screen. I'm not using left and right because I want left and right to be relative to the turtle, right? But like that's to the right. So I'm going to turn right again to be pointing south. T right by 90 degrees, right? Then I'm not going to use this. Okay. And then T color, let's pick a very bright blue. So it's like red, green, blue. That's my color. And I'm going to say T forward, say 100. That should draw a blue line from the top Okay. Bad color sequence, 0, 0, it's a string, 0 color. I need the screen. No, I need turtle. I need the turtle package itself. Probably going to put it here. Turtle dot, and it's color mode. Color mode, yeah, so that it will accept integers. I think otherwise it will be float. Is it if I do this? Not if I add this one. Just want to try. Yeah, okay, actually this did work. And will it work if I do now? If it go above 1, that doesn't. No, it does. It doesn't, right? So like instead of having that's pretty good. Let's use actually integer. Float. So 0 means no color. 1 is full range and full blue. Right. So I've got a line 100 tall starting from the middle of the top of the screen that just go down. I'm going to want to do a little Y shape, right? So I'm going to right T. I mean, that's if I'm zoomed in, that's the problem. It's kind of a little bit of a. How about tools in settings, font size, excellent, large, huge. Oh, that's too huge, but let's be 100% zoom. Let's go for large. I like this because then that way it zooms. The font is large, but then I can see as much of my turtle screen as possible. This is going to become relevant in a minute. Fine tune it. Cool. Right. Forward by 100. Very good. And let's say if I want a little bit of a Y shape, I'm going to turn right to start with by say 60 degree. That should split it nice evenly. And then again go forward by 100. And then I'm going to want to put the pen up. Then go backward 100. Then turn left by 60 to get back to the middle, and then kind of do it again immediately. I could do 120, but you'll see why. Now you know what? I'm gonna do 2 times 6. I'm gonna get myself the best of both worlds by doing 2 times 60 here. We'll see why in a bit. So now the turtle's going to be pointing southeast, and I put the pen down. Bracket. I'm going to make it go forward by 100 again. And then I just want to kind of go back to uh, go back to really, I just want to go back to the start for reasons again that will become clear in a second. To go back to the start, so I'm at the tip of this branch here. I want to go backwards. Let's put the pen up. Go backwards, backward by 100. And just to get obviously pointing the right way, I need to then go. So I've done right, then left, left, and then right again. So T right by 60. All right, let's see what this looks like. Oops, let's do it again from here, keeping an eye on this. Very good. Right. So that's a Y. That's kind of an even freeway split of the circle, right? They're kind of oriented like this. Um, hmm. Sorry, I'm pointing down, and then I need to go backwards again, 100 to go back to the beginning of the shape, right, to the top of this branch. I've done a Y shape. We're good. Okay. Now, what I'm gonna want to have is make that a function. So I'm just gonna say define a function called y underscore shape, which not gonna take anything. Well, so this and then this then becomes a little subprogram for the turtle to run. In fact, I'm gonna let's put the pen down just that we should start pen down, and I'm gonna say trunk. That's taking us forward. Then we do the right branch. Rewind. Right branch. Let's be nice. I've rewound it. To be honest, I should really do T left 60 because that's just part of rewinding, and then left branch. This is where we notice there's a lot of similarity and repetition, which means that even all of those things could sort of be made into functions themselves later on. But let's again. So left branch is the pen down again forward, and then rewind the left branch. Sorry, T left 60 to do yeah, I'm gonna T left 60 here, right? And because I've removed it from the two, I want to split the ones that kind of are about correcting, rewinding to the ones starting in the left branch. Same deal, to rewind the left branch, pen up backwards, and then go right by 60 to get to the middle, and then rewind trunk. It's a bit verbose, but it makes things a little bit neater and easier to follow. Nothing's changed to the oh yeah, this now does nothing, right? Because we have defined this little subroutine, but we haven't. I'm gonna light a scented candle. Summer nights. Summer night fragrance candle bougie parfumé. Right, so what we've done here is we've defined this one Y shape function that will make the turtle draw a Y shape, but we've not actually executed it. We've never called it. What I need to do, actually I'm going to move my color here and say just call Y shape. So just do a Y shape. Hey, just do a Y shape. What does it say? Why be so difficult about it, right? This is going to do Y shape. Now, what's interesting, what's already quite cool here is let's see. Let's say I want to do what I could be doing is actually go to 0, 0, and 4 underscore in range 6, call it 6. The nice little hexagonal symmetries are nice. Snowflakes, for instance. We are going to do Y shape and turn by 60 degrees. Oh, again 60. So for instance, because I've made this little function, I can reuse it, right? And because I get this function that returns me to the center, I'm kind of coming back to the, before and after Y shape, the turtle is exactly the same position. Probably not with the pen in the same. I start with pen down, but I'm going to leave with pen up. But because I start with pen down, it doesn't really matter. But yeah, I should really leave the pen in the same position as well. Now we get this. Now, if I were to instead do 12 and make that 30, ooh, 300. Well, okay, it doesn't expect it. For 300 is going to be minus 60, essentially. It's going to 60 degrees the other way around. So let's make that 30. This would look like this. I'm going to have overlapping little branches. So, I mean, immediately we see the advantage of subroutines. We can write something once and then call it in a bunch of contexts. Now, this is not all, right? What I could be doing is instead of using 100 here, I'm going to say it's going to accept an argument, as in a parameter I pass to it, not a fight. I'm going to take all of the hundreds, which I'm going to do by double clicking to select the word, and Command D, or Control if you're a PC person, keyboard, and then all of those, Tab D, and boom, I've replaced it by D. Which means that I want to run a Y shape for 100. Now, what it gets interesting is if you start having little, like if it's kind of spinning but not exactly dividing the circles really evenly and kind of overlapping a little bit, you're going to get some kind of irregularities. Right, doesn't come back to the same. What's happening? Right, fancy chair. Yeah, 30 is better. Now we can do. I mean, I like this. How could I? I could fade it out, right? Like T color. And then make that 24. And then make that this one divided by I. So I'm going to have little branches, and that didn't work. Float division, just fine. 125. Fine. We're going to start at 1 and finish at 24 by going to 25, avoiding the divide by 0 here. This will give us darker and darker. In fact, they get dark too quickly is a bit of a problem. Although if I did white, maybe I should give it simply gray to get a nice little middle. We can see the branches get darker and darker. In fact, I'm going to also say T, is it speed? Now, speed goes from 1 to 10, technically, but 0 is the fastest of all. Is that like just go as quickly as you can. I could also do T hide, probably. I'm not sure if I want to, yeah, hide turtle, fine. If I don't want the arrow, boom. Because I think the arrow sleuth is done as well. All right, so we already have something like, wow, okay, so imagine if this were instead to go to, I don't like my divisor, so okay, big N equal 50. This is going to go to big N, and this one is going to be so that's going to actually get them, start them dark. Start them dark and then get them more and more filled with that blue color, so that the last it will be, but spreading the fading of color. This is not what I was planning to do. This is not what I had rehearsed with the one I made earlier, but we're not even using recursion yet, but we are having fun with functions. What I can then do, because it's shape 100, I can also do something where it's getting smaller. So how would I do that? So like every Okay, 35 is a bit annoying though. So we're going to have 6, but then we're going to accrue 30, so we're going to have an extra 30. Okay, so I'm just not sure what to do. Y shape, if I want to... Ooh, that's a good one. I'm going to do something like an integer divide. How would I do that? Multiply by I. Now, divided by I integer divide. So every like 6 effectively of them, I want them to kind of get a bit shorter. Who knows what this gonna. I'm going off script. I'm judging it up. Yeah, I knew there was gonna be divide by 0, of course. Why though? Because I integer divide. Oh, because okay, I integer 6. Uh, uh, the last one. Ooh. This is where I want to put it. Okay. So they're going to start big, but then every 6, 6 is not enough. No, I got 6. I think I need like more because I'm going to 50, so maybe 10. Tack, and then smaller, and then smaller. I probably wanted 11 actually. Actually, it's 12. Sorry, in 30 instead of 30, it's going to be 12. Actually, 11. That's what I'm saying. So maybe I want this to be a bit. Well, do I want this to be larger? Anyway, there's fun to be had for all ages with functions and a little bit of this basic shape of doing the y. And I've not even made the angle a parameter, but because by making the distance a parameter and using kind of changing color, the thing, I can do some very fun stuff. But this is not what I wanted to be doing here. So let's go back to a Y shape at the very top for 100 long. So each branch is 100. They're going to be separated by 120 degrees because the angle is here. Let's do it from the top because we want to. I did keep it 0 and it's 350. And what's happened to the color? I must have removed the color. That makes sense. T dot color. Full blue, I reckon 001. And let's have it on the dark gray, black. Right, back here. Cool. Now, what if I said, okay, I'm not gonna do anything if the distance I was given, because like you'll see why. But I want my plan is that at the tip of it branch, we're gonna call the function again to make another y, but then in fact, I don't even need to draw the right branch. I can just kind of turn and then call it and then turn left. Yeah. Anyway, at the tip of the branch, I want to call the function again, but with a smaller value for the distance, so that it gets kind of smaller and smaller, like the one I've shown you earlier, in a sort of fractal way, like actual trees, obviously, or like blood vessels in lungs, right? Because it's the same thing. You're trying to just like spread something over as wide as possible a volume, or indeed in your brain, the blood vessels. Right. So what I want to do is that we could kind of go down. This will never end, right? Because we can divide and get smaller and smaller and smaller. So there has to be something where like, okay, if d is smaller than 10, then we're going to exit, like we return. Just we don't need brackets. So that's all. And this, when a recursive function is a function that calls itself, but for there not to be infinite recursion, like very much like we don't want infinite loops and iteration, there needs to be a base case that is some set of circumstances in which you're going to terminate the function, exit the function without calling the function again, and that's your kind of terminal point. So this is the base. case. And then instead of drawing the right branch, which is going forward, I'm going to keep going right, but I'm going to call Y shape, but this time of D multiply by the D ratio. So D ratio, I'm just going to make that a constant at the top. And let's make that 0.75. So it's going to get 3/4 shorter every step. So we call Y shape. We don't need to rewind we don't need to even rewind the branch. We just need to kind of then go left to put it back the middle. And then for the left branch, it starts with pen down, so I don't really need a pen down here. And then for this, just call Y shape. D multiplied by D ratio. D ratio. Then we go. So we've done the right branch. So from the top we've turned right, and then we turn back, and then we turn back, and then we go in the other one, and then we go back, and then we go backwards. And whoa! And then we pen up before going backwards. So surely. Oh, mind you, I can living there pen. So in a way, like the only bit that draws is here. Pen down and forward. All of the rest is kind of rewinding and being pen up. Let's see if this works. Okay, yeah, cool. So you know, this is kind of going already into the little like terminal branches, and things look very, very hexagonal because we're making them of equal length and spot on 60 degrees. Yeah, that is basic kind of doing recursion with fractals. If we were to I would start bigger. Could I start? I could probably start bigger, right? If I start instead making a 200, that means we're gonna have more generations before reaching the base case of kind of trying to do something smaller, shorter than 10, which is going to be even more intricate and detailed. Although equally, well, we'll see, right? This might take a long time to draw because the overall total complexity. I mean, I could get something like. I mean, I do have a console, right? So I can still print stuff if we want to kind of keep track of what's going on. So let's say n is my depth level, right? And then here we're just going to say every time we call Y shape, we just say, all right, we're now one deeper, right? It's like Inception. Okay, so what did I say? It was like control page down so I can see my chat. Hey, hi, Patco. Animation, Wilfred. Oh, this is Wilfred E, perhaps. Oh, they've been and gone, to be fair. So, well, they'll come back. This will be on the instant replay. Okay, as my fractal of hexagon draws, I'm nearly halfway through. I've never really completed fully the right branch, and you notice that the right branch spills over into the left side. Well, it's from the top, right? So it's the other way around. But like it's the right branch relative to the turtle spills over onto its left side, which is the right side of our screen. And now we're starting the left branch. Interestingly, they're not quite overlapping, but they're like very, very close together. And I could make this look okay. So I was doing this, right? I was saying let's keep track of how deep we are, and by every time we call it, we're just going to increment that, meaning that I'm going to start it at level 0. That's fair enough. And perhaps I could f string level curly's n. Okay, from the top. Now the printing is actually going to slow it down. I'm going to about like, so remember each call to Y shape spawns, if you will, forks, literally. Fork is also a system term when a thread then spawns a second thread that runs in parallel. 2 of them. So we see our maximum level is 11, and the previous level 10 has spawned 2 11s. And then it's gone back to, it's rewind this one, it's gone back to previous level 9, which is spawning the second 10 of this level 9, which is, right, which then has spawned two 11s. Oh, there's so much. And as so each line is the function y shape being called once, and most of them, because it's like there's only one at level 0 and there's two at level 1 and there's four at level yeah, so we're gonna have 2024. This is the the Wheaton chessboard problem. This is about geometric series. Oh, so I have my bookmark bar when I said I don't want it. What view? Uh, uh, yeah, maybe show the toolbar because I'm gonna struggle. Um, gonna have a lot of those, right? Because it is so just the number of like 2 power 11, right? The number of final turtles is 248, and then I need to like add 1024 to this for the level 10s, and then add 512 for the level 9s, and then add 256 for the level 8. You might recognize powers of 2, uh, and then add 128. Oops, 128, and add 64, and add 32, and 16, and 8, and 4, and 2, and 1. This is in fact 11 bits, so it's like the binary number of 11 bits where it's all ones is this number, and that is yeah, and as you'd expect, right, just like 495, which is one short of 496, the next power of 2. This one will speak to 10 GCSE. I told you there's something for all ages in that one. Really like it. Okay, that's pretty cool. I can make that I can make that even better if I could I could change the angles. In fact, I could make the angle a, at the moment it shows up all of there, right? I could make the angle an argument, parameter, uh, 60, 60, 60, and that's it. Replace that by a. This becomes a, so what if I make it a 45? And sorry, 45 at level 0. I might want to remove this as well. I'm going to comment it out because for y shape machine is n. And of course I need to pass. Let's say that we keep the same angles, but I could also have, and I will, have a ratio, just like I have a D ratio. So on the 45-degree one, right, it's less hexagonal, and you get those kind of shapes, so it's kind of still very, very regular. I could, of course, add a little bit of randomness to each. What time is it? Oh, yeah, half an hour in. Now, Turtle isn't the fastest way of rendering this. Processing would probably work better here, but the problem is that Replit takes forever to boot a processing repo, and this shows recursion much better because in processing would be like drawing lines between absolute coordinate. But equally in processing we could also animate it, so that if I move the mouse, that things like the angle could be changing live, or the length or the ratios. But yeah, that's so that's one way to go about this thing. Since I started with 200. Let's see if I get fewer generation by having node 0.7. Right, I'm kind of node 0.7 gets me much fewer generation. Of course, like my trunks and limbs are still quite long. Okay, whilst this draw, I'm going to improve this a little bit by having this a be an a multiplied by a underscore ratio, and see if I've got some scope to play with changing the angle a little bit. I could also do so. I want the well. Let's start with. I think they would overall tighten, right? Because you could make this so it fans more and more, but I think overall they would probably have a tendency to tighten. Let's make that node point. Let's have 0.7. Why not? 0.7 as well. Try this here. One more thing I can do, of course, as well is now this would be t. Actually, I could also have the width of the thing here, and before drawing anything, do t dot pen size W, and with that width, I will pass W. Actually, I'll pass W multiply W ratio. Another comma here. Should show you what's going on over here, right? It's not as nice as the previous, isn't it? Now, what I could do is keep a. Okay, I want actually a larger A ratio by looks of it. Add this as a parameter in the call. Define W ratio so that we are going to yeah 0.9 as well, I think, and start with a width of 10 pixels. Okay, that's something very fixed. So I'd like it to reduce quicker. I'm gonna have, how about 0.7? Yeah, that's more like it. What if I made that note 70, note 8? Now the fact that the line is thicker just makes this seem brighter because there's just more light coming up from the background. If I set it on a white background, so now I'm getting like branches that well, technically outside the canvas, but I could make that a 150, and on a white background, let's try it. Ooh, where'd that come from? Oh, I think that before I move the turtle to 0350, I need to take the pen up. Yeah, so now we can see that it's the same color, right? Because another thing I can do as well, so I've got DAW and then C for color. Now this is going to be a bit fiddly, but because colors come with like 3 numbers at the very least, but let's have this being 0, 0, C, so it's just across one dimension of blue, and then I'm going to start with a C of 1, 1.0, because that's the float. Well, I can pass a 1. And here, after the W, we get, you know what, I'm going to start making it look a bit nicer by indenting the parameters. This is the same, it's just a styling thing. And so in here, I can have a C multiplied by C underscore ratio. Now, this is where, so if I start at 1, which is full, and I can get it to go darker and darker, which on the white background is going to work, but on the black, not so much. N. That's because I need this, right? Yeah, okay. And then this also is what I'm calling here. Super. Still drawing. I think it's sort of coming back. Da, 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 da. I mean, most of it is outside the screen, so it's a bit unfortunate. But we should start. It's going to be when it does that. Well, start doing kind of that left branch. Not printing the depths number. Fine. I've changed it enough. C ratio, and of course my C ratio. So I'm going to start full blue and move my way. Well, start by moving my way down, I suppose, with 0.9. Why not? Ooh. I have changed a number of things. It's going to be kind of very intricate here. That's only 150 here, so we may have even a fewer generations. what I could do is have actually a hard limit based on the depth, right? So let's say I don't want more than 10 levels of depth instead of saying like, because some of my, which means that if I put like high ratios of distance, if I don't shorten enough every generation, um, I run the risk of like it running for very long because it's going to take a lot of generation before it hits. Okay, and let's actually make that like max depth, and that's like max. So on this one, I can probably afford this to be 11. But every time, right, like literally every time it's an extra generation, we are doubling the total number of calls to Y shape, the total complexity of the algorithm. It's a logarithmic, or indeed exponential in an instance. It's geometric, again, progression. Max depth equal 10. Look, my blue tree. Blue, and like the branch is subtle, but the branches should be getting darker. I could also start it at 0.1 and have something where my C ratio instead doubles every time. Yeah, at some point it's gonna. So the problem with this is, yeah, I need to. So how would I do this? I can simply here say C becomes equal to the minimum of C and 1. So if C is larger than 1, it will max out at 1 without throwing an error. It will just going to be full color. I think we might be reaching the full color a bit too quickly on this one. Yes, probably. What if I made this? Okay, what if I made this 1.3? I don't understand. At zero point 0.1, it shouldn't look that blue. I don't. Oh, sorry, because I've called. Sorry, that's not the one I want to change. That's the one I want to put at zero point 0.1. Right, so it starts black and then gets bluer. That's an option. That's nice. In fact, I would probably like. Okay, let's go for a nice neutral gray background. Everyone loves a bit of gray. Splendidly, conveniently in the middle, between black and white. We're getting the best of both worlds. Tick this one, and then takes a little bit to run back, but we get that one, and then we're gonna have this guy, and the next one is here, here, here. Left, 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 left branch. Right, so you notice it goes all the way to the right and then backtracks. Now, we can make any number of shapes. I decided to do something branching, but I could have like fractal little triangles, or as long as it's something that from one kind of edge of it, we can start drawing a smaller version of the shape again. The world truly is our oyster. Something else I could do as well is have it start in the middle, pointing down, and then do this kind of thing. But maybe of like, okay, maybe only. I liked having 10. It's nice and rich, but like if 9 is like suddenly half the complexity. 4 underscore in range 6, radial symmetry. Oh no, that's not what I'm after. What I wanted to change is this, make that be 9 actually. The maximum depth, right? So now I'm gonna have like one fewer, so it's much quicker to draw the branches because like it doesn't have like a final pair at the end. Now this is just the first of the tree, and I should have like a six-way symmetry. Um, a bit boring at 45 degree, though, right? Like, so how about like I start them. Also, they're gonna be a bit more. What's my A ratio? Make that 0.8. My D ratio, make that note 7. Width ratio, I'm happy with that. Color ratio, yeah. Max depth 9. Okay, try it again. Mm. Well, there's going to be 6 of those, right? So it's going to be that's might be worth one in the end. Looking a bit, it's going to end up looking quite bushy, I expect. So we see that at the moment we don't use like really kind of, this looks a lot more natural, right? This looks a lot more like an actual tree. A bit upside down and going from black to blue, but yeah, that's the fun of it. Um, than my very geometry, particularly with like 60s when it was all hexagon all the way. Uh, I'm quite curious to see how long this kind of, okay, so T start is equal to time. At start. That's going to be a float, probably a timestamp, don't really care. And then end print. So my hope is that this should tell me how long this completely took to run, which again, I've cranked it up at like speed 0, which is like as fast as it goes. I do believe that not showing the turtle goes a bit faster as well, but like the sheer, double every generation very quickly. I mean, I've capped it at 9, which should be 512, but that means there's a total of 512 at the final, like the very, very tips of the branches, the leaves. But we need to double that for all of the branches that takes us all the way there. So that makes it 1024, and then there's going to be multiplied by 6. So 6,000 of this. If I'm always going to tweak it and rerun it, I'm never going to let it chance to kind of follow. And it's also likely that it's the superposition of the 6 radially symmetric trees that will be the beauty of this final sketch. No, I could have something that trebles, right? That spawns 3 branches every time. That's another. I mean, I can maximize this, but it's not like it's gonna change much. Oh, a couple more. Oh, those are the total views rather than concurrent viewers. Okay, so 8 people have seen this. Well, what's going on with Turtle? Hey. So next one should come here. Yeah, and then the next one will be this one. Yeah, and then there's one bit here. And that's the final. And then now at the right of the next tree. So I like how the kind of their rightmost branch. So then the fourth tree, I've not printed the time we started, but I've made a note of it here, and it should give me the. Hopefully that's going to come out in seconds. I'm pretty sure, or milliseconds. We'll find out. Mm, 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 mm. I think I could have started shorter. That's what I kind of started to do actually. I could have started at 120 and maybe, well, I don't know if like the color. I'm happy with thickness, color, maybe an angle. Um, Angle and angle ratio I'm happy with. It's more like the start and distance ratio. I think it's shortened, so it's like I might start shorter and then make that ratio 75 just a second time. I gotta I at the time I've been live. No, it's not this. Is it maybe in OBS? We need to finish. We have done the right hand side of that tree. It's going to finish that one. Is that the last one? And then maybe I will perhaps see something here. Oh, I know. Well, I could really do a second hour this time doing object because of course, right? When I do this is again A level. This, right? I'm calling the constructor of the turtle, capital T. That's how we know class, and that gives me an instance of the turtle. Of the turtle object, an object of the turtle class, an instance of the turtle class, on which I call methods with that dot notation. Um, So things like when I set the color or the speed or even its like position and so on, those are kind of internal attributes of it. Okay, 309 seconds, right? So a good 5 minutes to generate, but we can make even prettier. So I was thinking Note 75 and 120. I wonder if instead of having the same turtle draw everything, I could make the turtle like just spawned two copies of itself that should notionally therefore be kind of like run the whole thing all in parallel. Not for the six to be honest, but like more as far as the tree is concerned. Um, so in order to do this, okay, let's leave that as I'm just going to put that back here and leave that on the side so you can enjoy watching it whilst I refactor this. Okay, so instead of t, whenever it says t is in my y shape, t dot, t dot, t, I'm going to say self dot. This means that this will call it on the self. I need to pass self as an argument. Same deal, I am also going to do self.yshape because it will also belong, yshape will also belong. Well, let's not do that just yet. We don't care. Let's see. Let's say I have, what I need is a class cloning turtle, which inherits turtle. So it's a child of the turtle class. Actually, turtle.turtle. When I'm going to say turtle, I'm going to say turtles. Now, so what I can do is instead, no, because I don't need to. No, let's do turtle.turtle. So I've imported the turtle lowercase t package, right? And inside of it is a turtle class. So I need to say my cloning turtle is a class that inherits the regular turtle class. Turtle, right? In that turtle class, I have a method called yshape. Whoa. Right, which throws a Y shape. That's kind of fair enough. And I'm going to say t equal cloning turtle bracket. So by default, I don't have to define another return constructor. I should call this constructor of the parent class, I hope. So just create it and then call white shape on it, but like passing it a all of the arguments as we did. And so that means that this bit, everything that comes before, like the line, and that probably just all the way to the carriage return. I'm just going to say here and say this is not this, right? I create a turtle and call the Y-shape method in it. And is that it? Right. And no, sorry, that's not quite it. I have, so I'm going to move this to the top. I'm going to move this I'm going to move this to the top. Well, above, certainly, not the very top, but like whatever, that's define my class. And to begin is going to be it's not going to be a turtle, it's going to be a cloning turtle. That's T, which means, and then I'm also going to say T dot Y shape. And, whoa, okay. I see what's going on. The problem is that when I create a turtle, I don't create it in the same position and orientation. And indeed, with all of those parameters, this is annoying. This is super annoying. Now, what parameters do I have in my turtle constructor? I mean, of course, I had logged in. No, I didn't. But really, okay, this should be our reference. Ba-ba-da-ba-da. Basic drawing, make an object-oriented class. Hello. Right. Muscles are on screen at once. Yay! Right. What's in the turtle constructor? Is that it? It's just, are you gonna, is that, okay, well, I mean, surely the replit will tell me what's in the turtle constructor. If I say turtle, the turtle bracket, undo buffer side. So that's not what I want, but I can still change all of that stuff with no problem. So, uh, uh-uh. Let's get turtle. Get turtle. Return turtle object is self. I mean, can I clone the self by just saying, hold on, surely. A good constructor, right, will accept a copy of the same object to initialize all of the attributes the same way, right? So if I say this is actually a cloning turtle of the self, waiting, no, it broke, it did break, because, yes, definitely in this one, because key error. Okay, cloning turtle object at screen shapes index. Row turtle in it, so this is the constructor of the turtle, which creates an image, a turtle screen, or a private turtle image, set the shape. It doesn't have the underscore. Okay, fine. Okay, turtle. All I need to do is get all I need to do is I mean things like the thickness of the pen, the color are going to be taken care of because they're in Y whatever, right? Draw a Y shape. So what am I looking for? Position. Position, home, pause. Right, so that's just pause, right? So I can say, right, I create it and I said T go to self.pause. I'll do a bunch of stuff and I'll copy it twice. Also, then there's the, how do I know where it points? Clear screen, orientation, heading, excellent. Yeah, but heading, okay. I think what's interesting about Turtle is that you can usually the functions if you call them with nothing, that's polymorphism technically. All right, so that's yeah 12. If you call them with nothing, it will just return stuff. They will act as an accessor, a getter, and if you call them with something, it will actually set it to that. So the turtle state. Ooh, the turtle is a mode. Okay, it's probably relative or absolute, I'm guessing. Mode, logo or word? Okay, so we are so because the heading will be given, yes, I like that. Yes. Okay. Excellent. Because it's like relative to this, I just need to turn left by the heading. So I just need my clone T to turn left by the heading of self. I have well, yeah, I can't do that. That's the problem. So I don't want to be doing that. I just want to be kind of like copying. And I think those are only the only ones I need. Otherwise, it was kind of drawing the thing and doing the thing with the right shape and distance and angle. Maybe not the angles. Maybe not the angles, which was a bit weird, I'm not gonna lie, but oh yes, but no, it was doing the angles, but because they were being reset. Ah, now wait. So actually, I don't want it's not the heading. Well, no, it is the heading because I've kind of set the self to point the way I wanted it, so I can live with that. But really, that should be A. I mean, should yeah, I can work. Fine, that should work. Ah, okay. It appears to be doing this sequentially though, which well, I guess to be fair, it starts to run it in certain order. So I can have several turtles on the screen. Yeah. So the go-to, sorry, I'm just going to say like tape and up before going to. All right, that's our problem here. So I can't. It doesn't seem like it's not. Doesn't seem like yeah. Doesn't seem like it's going to be like sort of forking turtles and creating a whole bunch like to run in parallel. Um, although, oh no, in Scratch. Can I do that in Scratch? I think that there's a total module, but like it's not that each sprite can be a yeah, and also because I also need to do a T hide, was it? Like T hide turtle. Mm. Oh, that's disappointing. Still nice bits of like, object-oriented inheritance and made a method and but it's if anything it is going slower. Very good. Uh, well, all I have to do is simply rewind everything so that I don't where my max depth, ratio graph, find range, print the time, import time, start time, end time, time. Oof, this is what I'm doing a self. Yes. Restore to here. Oh, that's good. So the restoring is non-destructive is just going to add this. Yeah, you've read the message like yourself, I'm sure. Okay, that what recursion with turtle, so a recursive function like the one that does the Y shape is a function that calls itself. It calls itself with like slightly tweaked parameters. In particular, there's an n as the number of generation, and so I have a base case that guarantees I'm not going to be recurring forever, the recursive equivalent of infinite iteration. Um, and everything that can be done with iteration can be done with recursion, often more elegantly. Um, and this, I mean, iteration is the sort of Turing engineering view of the world. Recursion is the sort of Haskell Curry and Alonzo Church, which were his forefathers in mathematics, um, kind of, and computer science as mathematics, functional programming view of the world. They're not, but I can see why. To be fair, I can see why we would favor the engineering approach, particularly like stressing on OOP rather than functional. However, just in case there's someone that's like in high school that's listening to this, the great strength of functional programming is that because it's got no state, any kind of function evaluation can be like deferred to like other computers. And in fact, especially with partial application, the fact you're currying and it's always like a function of one argument that gives you something. Well, actually, this argument, the moment you have a return value that can becomes you can use that to curry the function call and have the kind of next higher level of function be ready to accept the other arguments, which means that you can distribute this across a number of computers. I say a number of computers because definitely that's how kind of great computers, great computing data centers, etc. And Google, right, famously in 1998 for searching for like huge data sets, etc. That's kind of big data. However, Nowadays, like your basic CPU, let alone your GPU, are all multi-cores. And if you really want to take advantage of the multi-core functionality, particularly in high-end gaming, right? That's where functional programming that allows you to parallelize things is a plus. So functional programming is coming back to the fore because ensuring thread safety and like handling parallelized stuff when there's meant to be a shared state is self-evidently, I'm assuming my audience doesn't need this explained to them, a bit of a integrity and conflict of concurrent access nightmare. That's the difference. That's like if you've ever tried to edit a document on a shared network drive and someone has a lock on it because they've got it open, so you can't, you're being a read-only version, etc. So I do feel like there's more value. But that functional programming and things like recursion are not as challenging as the order in which like things are delivered would have you believe. I think that things like recursion through Turtle are accessible to children, and indeed, and like the whole point of Logo and Turtle was to make programming, but in this instance, functional programming. Um, yeah, yeah, of course. Um, Yeah, it needn't be complicated. It needn't be like particularly A level, right? Anyone who can rock turtle and understand a function should do it. Could grasp it and will. And so that was recursion. But remember, recursive calls itself. It needs to be a base case, so we don't do it forever. Um, and in that instance, also calling itself twice. So this is something like the merge sort which we get students, and yeah, it tends to be on the GCSE specification, so that's like middle school, end of middle school in the UK, as kind of understanding it, but not necessarily being able to implement it. Well, definitely not being able to implement it because it requires recursion, and this is something that, well, I ask my students to implement, or I show them how it is actually implemented using recursion in like senior high school. Um, but that merge shows do something right. It's divide and conquer. When you get something like this, if let's say, speaking of like fractal and branches, the reason that a tree, particularly in winter, we really see just the branches, looks like the set of blood vessels in lungs, looks like the set of blood vessels in, I suppose, the liver. Again, maybe the liver's got different constraint, but definitely like our brains or other brains, to be fair. That's because you're trying to cover the maximum amount of volume, and it's a good strategy to do this. So in a way, if we were kind of like the turtle was searching in a space, that's not a bad strategy to do it. Whereas like iteration would have you kind of like really just scan and then do loops within loops. It's probably going to be more like this actually, right? Um, so that's this, and those parameters, simple tweaks, and the idea that so that's also divide and conquer. I could have something where I I could also do it. All right, let's go cray. I'm going to do it a third time, and so I'm going to start with an angle instead of smaller angle of say 25 degrees, and then again now I have still six wave symmetry, but each branch should now have three branches with 20 degrees each. Although the way I've done it, it may be that the first two are kind of centered, and then with where come back the event, we can already see that it's slower. And that's because of the third branch, of which we may be able to see some over there. Let's see. I shouldn't necessarily look. Oh, maybe I messed it up. Didn't I? Turn right, turn left. But those cancel each other out. So I'm just kind of like drawing it. What have I done? No, that's not what I want to be doing. Is it? Turn left again. Let's say turn left. Then say turn left again. Yes, I wanted it inserted in here rather than the top because at the moment I've got two that are on top of each other. Is this free? Yeah, it's free, but like one on one side and two on the other, which is nice, which is quite nice. I say on one side, it doesn't really matter because ultimately the free branches are going to be, how are they? I'm not sure. I think maybe the angle is there twice on one side and only once on the other. I'm not, it looks pretty for sure. Is it really forking three times? It should. Yeah, and that's the third branch. But it looks like, yeah, it's done this one and then done it again and then added one just off this end. So we could actually make it four. We could totes make it four, couldn't we? How would I do that? I would do right, and then I would, sorry, I'm going to take this, uh, right and left, just like I put one in between the here, and then put it here. And this is going to give me four branches now. I hope you have a lot of time on your hands. Okay, can I probably just go to OBS and give me just the code, which is this one, fade, mute my microphone, and let you enjoy this excellent, no, that's not mute.